This is June 14 SS05 paper, and is an example of calculating, or testing rather, a standard deviation against a hypothesized value. In this question we're given 12 cartons of milk, and we are given the capacities as they've been taken off the sample. We're asked to investigate the claim that the standard deviation of the volume of milk delivered by the filling machine is 30 millilitres. We're going to use the 5% level of significance. As with any hypothesis test, the first thing to do is to write our null hypothesis, which is that the standard deviation is equal to 30. We weren't given any direction here, so we're going to test the alternative hypothesis that sigma is not equal to 30. It's a two-tailed test, and the level of significance is 5%. The first thing that we need to do in order to carry out this test is to calculate the sample standard deviation for these numbers. That would be done on either one of the calculators, the standard graphical calculator or a basic calculator. And the value that you get there using the n-1 formula is that the standard deviation is equal to 38.2. In our calculation and test statistic down below, we're going to use that in squared form, and that value squared is 1460. The formula that we're going to use is n-1 multiplied by s squared divided by the hypothesized value here for sigma. So substituting in our numbers, we have 12 items of data, so n-1 is going to be 11. I'm going to multiply that by s squared, which is 1460, and divide that by the hypothesized value squared, 30 squared, on the bottom. And that gives me a test statistic, if you carry out the calculation, of 17.85. I then need to compare that with critical values. The distribution which is appropriate for this is the chi-squared distribution. I've got a two-tailed test, a two-tailed 5% test, so the values that I'm looking for here are where I have 2.5% in the upper tail or 2.5% down in the lower tail, and my critical values are going to be on that basis with 11 degrees of freedom, 3.816, or at the top end 21.920. And it's always going to be the case with these. It's advisable to draw a diagram. It's the upper tail actually that I'm going to be interested in. So 21.92 is the critical value. Chi-squared is positively skewed, so it looks like that. My test statistic is 17.85. So we can see from that the test statistic does not lie in the critical region. So test stat not in critical region. So we, on the basis of that, will accept date 0 and conclude that we've no evidence that the standard deviation is not 30 millilitres. Just look back to the question and make sure that nothing else is left to be done, and no, that's my 8 marks concluded there. So accept H0, and you would need to write the contextual conclusion down the bottom as well. We accept H0 and conclude that we have no evidence that the standard deviation differs from 30 millilitres.